and welcome to the NPTEL course on Mechanical and Electrical Systems of Mining Machines. Today we are going to start module 2, that is the Mechanical Systems in HEMM. The Electrical Systems in HEMM will be covered by my counterpart Professor Aurobinda Rautrai. So, he will be starting with the basics of electrical systems and the electrical systems in HEMM. After I finish my lectures, that is lecture 30th would be the last lecture where I will be finishing and he would be starting. When we talk about the mechanical systems in HEMM, so the first HEMM that we would be discussing is shovel. So, there are many HEMMs, that is heavy earth moving machineries like HEMM, payloader, drag line, bucket wheel excavator. Even there are machines which are used in underground mines like continuous miner, shearers, LHD, SDL. So, those also we will be touching upon a bit, but when we are talking about HEMMs, we will be first talking about these heavy machineries like shovel, then we will go to bucket wheel excavator, then we will go to drag line, and then we will be touch upon some of the transport and auxiliary machineries. So, today we will be starting with the power transmission, that is the mechanical transmission that happens in shovel. So, this topic would be covering, first we will be going to the introduction of what a shovel is, then we will be going to the general construction of shovel, then thereafter we will be going through the classification of a shovel, thereafter we will be in details we will be discussing the power transmission system of how the power transmission happens through the different mechanical components in a shovel. Thereafter we will be going to the undercarriage unit and the power transmission in front attachment. Well, when we start with the shovel, so in the first overview slide I have discussed about what a shovel is. So, there are many kinds of excavators. So, again in excavators we have intermittent discharge type and continuous discharge type machines, and among them shovel is one of the intermittent discharge type machines. So, which helps in excavating the earth, like digging, loading or moving massive amount of earth, rock or mineral, while in construction, mining or as well in demolition, this kind of excavators are being used. Now, when we visualize a shovel, you can see here in this picture, this picture shows us a rope shovel. So, this is one of the modern rope shovel that you may find in various mines. So, when we visualize this shovel, we visualize this in three parts like a human body. So, it has a head which we call it as the top or revolving unit. So, this is the head of the shovel. Then it has legs which are the crawler units. So, you can see these are the crawler units. So, this we call as the leg, which helps in the forward and backward movement of the shovel, and then it has arms and hands. So, which are the frontal attachment. So, here you can see these are the frontal attachments. So, which in this we call this as the boom, this is the dipper stick and this is the bucket. Now, the operation of the boom, bucket and dipper stick happens with rope. So, that is why we call it as a rope shovel. However, when we first saw a shovel, it was back in 1835. It was not looking as fancy as it is looking in the picture. It was looking somewhat like this. So, this is the picture of a first kind of the shovel, where you can see this is made up of wood or of wooden materials, and here this is powered by a steam engine and it is moving on tracks. So, these are some of the facts on shovel that you should be knowing about. However, nowadays what you see is this kind of shovels have left the tracks and have become crawler mounted. So, which gives the easy maneuverability and movability for this kind of machines. it is not only constrained to the tracks where the tracks are laid, so its movement is not constrained to those tracks, but it can move anywhere. You earlier this kind of shovels, they were very slow in action and they were very clumsy, but nowadays with the upgradation of the technology, or the new technology that has come up, with that these shovels have become very efficient and fast. So not only on crawler tracks you would find this kind of shovels, but also you would find them as a on rubber tire mounted. When we talk about shovel, it is one of the oldest types of excavators that is being used in open cast mines. So this kind of machines you will generally find in open cast mine. This is a open cast mine machine. You can also see it in construction sites, many of the construction sites, but they have different variants as well. There is hydraulic shovel as well, which we call it as the non-rope shovel. There is also electric shovels, and there are also the shovels where the bucket is towards the head and the leg, which we call it as a backhoe shovel. So them you also can find in various construction sites. However, when we are talking about these mining machines, we will specifically see them in open cast mining projects or in quarry mining projects. Now when we talk about the general construction of these machines, so the first and foremost component is the powerhouse, that is from where the power is generated for the operation of the different components of these machines. So which we have understood that it would be, if it is not a steam engine, which is an external combustion engine, it would be nowadays it would be an internal combustion engine. Now in internal combustion engine, due to the heavy duty operations of this kind of machines, so there is a need of a diesel engine rather a petrol engine, which would not be able to generate the amount of power that a diesel engine can provide. This depends on the type, because it all depends on the type of the fuel, the characteristics of the fuel, and the way the operation happens in the internal combustion engine. It gives a lot of power which is required for the operations of this kind of heavy machineries. Now the crawler, this is the head which houses the engine room, and then comes the leg, which are the crawlers. In the head there is also the operator's cabin which is present, and there is also the turntable which helps in the swinging action of this complete machine. Like it can stand at one place and it can rotate 360 degree to have different operations. So the generally mostly in mines you would find a shovel dumper combination, which is quite common. You would see that a shovel, there would be multiple dump trucks would be coming and stationed beside the shovel, and the shovel would be doing the digging action and then dumping it onto the dump trucks. Now when we talk about the other components, it has the arms and hands, which is the boom, and you can see there is a pulley at the top of the boom. So the boom is directly handled by again ropes, which is attached to this A frame, and then there is a dipper stick, and then there is a bucket which is attached to one end of the dipper stick. So through this pulley, this bucket, the one end of the bucket and the dipper stick is handled by a rope that goes through this pulley, and it goes onto the A frame. Now the sheaves onto which these ropes would wind onto is housed again onto this turntable or the head of this shovel. Now all the power transmission systems, that is the crowding and hoist mechanism, which we will be discussing in a while. The crowding is for the bucket, that the bucket would penetrate into the virgin rock, and then it would do the excavation. So and the hoisting action is for the bucket. The bucket would move up and down and the boom would move up and down. So these two hoisting mechanisms of the bucket and the boom with the crowding mechanism of the bucket, all these mechanisms are housed on this turntable only. So there is this travel mechanism which is the crawler. Again the mechanism is controlled from the superstructure, and the swinging mechanism is also on the superstructure, which helps in the swinging of this complete shovel. So there is this undercarriage unit which we call it as the crawler, and then there is this front attachment. So at the end I will be showing you a line diagram of how the power gets transmitted from the superstructure onto these different components, so that there is a smooth operation of this shovel. Now, as I have explained in the last slide, so this shovel consists of a bucket and a dipper stick. Now, as you can see clearly, the one end of the bucket and the front of the dipper stick are attached to a rope which moves through the pulley onto, and this rope goes onto a sheave which is on the superstructure. So this helps in upward and downward movement of the dipper stick. However, the other end of this dipper stick is attached to the rack and pinion arrangement which is housed inside this boom, or we can say it as a shipper's shaft. So this shipper's shaft helps in the forward and backward movement of the dipper sticks. So let me just explain you in a bit that how this shovel operates. So now when the boom gets hoisted to certain locations and it is fixed there, it is not moved continuously. However, for the crowding action, this bucket is lifted by using the ropes that goes over this pulley, and the dipper stick would move forward to help the bucket to do the crowding action, that is penetrating into the virgin rock and taking out the material with the bucket, and then swinging it. The superstructure would swing and dump it onto the drum truck. So for the crowding operation, the forward and backward movement of dipper stick is very much necessary. Now this pinions that we have been discussing, the rack is onto the dipper stick, and the pinions that helps in the forward and backward movement of the dipper stick is housed inside this heavy structural member which we call it as the boom. Now we can see that the boom is pivoted at its underside with the turntable. So with this turntable, this boom, one end of the boom is attached, and at the other end the boom is held by a cable, which we can see these are the cables which again the sheaves are housed onto the superstructure. So and at the bottom there are the crawler mechanisms which helps in supporting the complete superstructure and the forward and backward movement of this complete machine. So here is a video that shows of how a shovel operates. You can see this is the crowding action that is taking place, and this is the dumping action that is taking place. These all are the rope shovels. So this is the crowding action, swinging action, and dumping action onto a dump truck. So now coming to the classifications of a shovel. So the shovels are classified based on various factors like the working agent, the bucket size, or the working mechanism. So when we talk about the working agent, they can be the diesel shovel, which is where the power is supplied by a diesel engine. They can be a electric shovel where the power is applied by the electric motors, or they can be hydraulic shovels. So in hydraulic shovels, it is not particularly a working agent which should drive, but it helps in smooth operation of the shovel. So, if like either it can be a diesel or a electric shovel, for a rope shovel or for a non-rope shovel. When we talk about a non-rope shovel, it is particularly a hydraulic shovel. Well, when we talk about the bucket size or the bucket capacity, they are divided into three types again. One is a commercial type power shovel, one is a quarry mine type shovel, and the third is the large quarry mine type shovel. Well, when we talk about these three types, again they are divided or classified based on the bucket capacity. So, if the bucket capacity is from 0.275 cubic meter to 1.8 cubic meter, so we call it as a commercial type power shovel. If the bucket capacity is from 1.8 cubic meter to 15 cubic meter, so we tell it as a quarry mine type shovel, and if it is from 15 cubic meter to 75 cubic meter or more, we call it as a large quarry mine type shovel. Now, when we talk about the working mechanism, they can be rope shovel or they can be non-rope shovel. Here, as we were talking about the working agent, so a rope shovel or a non-rope shovel can be a diesel shovel or a electric shovel, depending on the power house of where the power is getting generated and what kind of power, which helps in driving the different components of the shovel. However, when we talk about a non-rope shovel, it is controlled by piston cylinder arrangement, and this generally is a hydraulic shovel. Well, in rope shovel you would find a bucket, dipper stick and a boom. However, in a non-rope shovel you will find different configurations where they have the piston cylinder arrangement for the lifting of the cylinders. They specifically do not have any boom, but there is a frontal attachment which carries the bucket. Now, when we talk about the power transmission systems, particularly the mechanical power transmission system in a shovel, so the engine, that is the powerhouse, here we have taken it as a diesel engine. So, a diesel engine, when it generates the power, it gives particularly power to three different shafts. So, one is a swing and propel shaft, then the second is the boom hoist shaft, and the third is the crowd and bucket hoist shaft. So, this is boom hoist shaft. So, so this crowd and bucket hoist shaft, we call it as the CBH shaft. The boom hoist shaft, we call it as a BH shaft, and swing and propel shaft, we call it as a SP shaft. Now, let us try to understand it in details. So, here this is the diesel engine which generates the power, and this gives it to a torque converter. A torque converter is generally a gearbox which should change the torque to the required speed or required torque, and then it would give it to a gear or a sprocket which is housed on this engine shaft. Now, since this is a chain and sprocket arrangement, so here you can see on the swing and propel shaft as well, there is another sprocket. These two sprockets, you can imagine it as the two sprockets of the cycle that you ride. So, and then on them there is a chain which moves through it. So, now let us try to see the directional component as well. Let us say the engine shaft is rotating in anti-clockwise direction. anti-clockwise direction. So, the swing and propel shaft will also rotate in anti-clockwise direction. Now, there is another gear which is housed on this swing and propel shaft, which is rotating in anti-clockwise direction, because this is keyed to this shaft and this shaft is moving in anti-clockwise direction. So, this gear is moving in anti-clockwise direction. Now, this gear is meshed with the gear that is housed on the boom hoist shaft. So, now this is the gear that is in mesh with the gear that is on the boom hoist shaft. So, my boom hoist shaft will be rotating in clockwise direction. Now, again when my gear that is on the crowd and bucket hoist shaft, this is one gear. So, now it is in mesh with the gear that is on the boom hoist shaft. So, this will be rotating in anti-clockwise direction. So, since this gear is rotating in clockwise direction, this shaft will also rotate in clockwise direction, and the crowd and bucket hoist shaft, which is rotating in anti-clockwise direction. Since this gear is rotating in anti-clockwise direction, my crowd and bucket hoist shaft will also rotate in anti-clockwise direction. Now, coming to the mechanisms that happened inside this crowd and bucket hoist shaft. So, here we see there is a free boom drum which is attached to the bucket. So, and there is a band clutch here in. So, now this band clutch is keyed to this is keyed to the shaft. However, this free boom drum, it is not keyed to the shaft, this crowd and bucket hoist shaft. So, when my crowd and bucket hoist shaft is rotating in anti-clockwise direction, my drum band clutch is also rotating in anti-clockwise direction. Now, when I need to raise my bucket, so what will I do? I will engage the drum band clutch with the free boom drum. So, now when it gets attached to this free boom drum, so my free boom drum starts rotating anti-clockwise direction. So, when it starts rotating anti-clockwise direction, it starts winding the wire or the rope that goes over that is attached to this bucket. Now, my bucket starts lifting up. So, until the time I keep my drum band clutch that is keyed to this crowd and bucket hoist shaft attached to this free boom drum. So, my winding will continue and my bucket gets hoisted. However, when it gets disengaged, this drum band clutch gets disengaged from this free boom drum, my free boom drum will unwind the bucket. So, in order to control falling of the bucket, so this bucket will fall under its own gravity. So, there are two brakes which are attached onto this clutch, which helps in control falling of the bucket under its own weight. So, the same thing when my dipper stick has to move forward and backward. So, now there is another band clutch here. So, which has to be which gets attached to this twin sprocket. So, there are two sprockets, one sprocket is here and the other sprocket is here, which are attached to this shipper shaft. So, there is another sprocket here. So, this is the other sprocket which is attached, which is housed on this shipper shaft. So, now when my band clutch gets engaged with this twin sprocket, rather I would say one sprocket of this twin sprocket. So, this twin sprocket also starts rotating in anti-clockwise direction. So, this band clutch is again keyed and this twin sprocket is not keyed to the crowd and bucket hoist shaft. So, when this band clutch gets engaged with this or comes in contact with this twin sprocket, so it starts rotating in anti-clockwise direction. So, this sprocket also starts rotating in anti-clockwise direction. So, when it starts rotating in anti-clockwise direction, so it would push this crowd pinion. So, this is crowd pinion. These two crowd pinions would push the dipper stick to move forward. So, since now you can imagine they are rotating in, this is rotating in anti-clockwise direction. So, the crowd pinion, they are rotating in anti-clockwise direction. So, they would be pushing the dipper stick towards the front. Now, again the dipper stick has to move back. How it would move back? Now, we just cannot change the direction of this twin sprocket as it is rotating in anti-clockwise direction. So, this is sprocket 1, this is sprocket 1, this is sprocket 2 of the twin sprocket. So, this 2 makes the twin sprocket. So, what is being done is now this band clutch is disengaged and now this cone clutch that is on the boom hoist shaft is engaged. So, that now on this gear that is onto this boom hoist shaft is rotating in clockwise direction, but this is also not keyed. This gear is also not keyed to the boom hoist shaft. So, here to engage this boom hoist shaft to rotate in clockwise direction, this cone clutch is engaged with this gear. Now, this gear also starts rotating in clockwise direction. Now, when this S2 starts rotating in clockwise direction, so this crowd pinion, it would be also moving in the clockwise direction, because now instead of S1 it is engaged with S2. The S2 is rotating, this band clutch is disengaged. So, there is no movement of S1. Now, since we engage this cone clutch, so the S2 would be rotating in clockwise direction. So, my S1 is also rotating in clockwise direction, because there is no engagement of this band clutch here. So, my S1 and S2 rotates in clockwise direction, that leads to the clockwise direction of this sprocket that is housed on the shipper shaft, and this leads to the clockwise direction movement of the crowd pinion, and that leads to the backward movement of the dipper stick. So, I hope you understood how the dipper stick is moving forward and backward. So, let me just reiterate again. For this crowd and bucket hoist shaft, when it is rotating in anti-clockwise direction, so there is a drum band clutch and then there is a free boom drum. So, when this clutch is drum band clutch is engaged with this free boom drum, So, the rope that moves over this pulley and which is attached to one end of this bucket helps in rising of the bucket. Now, the bucket has moved up, it has been hoisted. However, how do it falls? How does it falls? It has to fall under its own weight. So, that is why there are two brakes which are applied onto this clutch, which helps in controlled unwinding of this rope that is attached to one end of this bucket, which helps in dropping of the bucket. So, the same way when the bucket is moved up or down with this clutch, the same way the band clutch gets engaged with this sprocket that is on the crowd and bucket hoist shaft, which helps in the anti-clockwise movement of the this sprocket, which leads to the anti-clockwise movement of the crowd pinion, which pushes the dipper stick towards the front. Now, when my dipper stick has to move back, this band clutch has to be disengaged and this cone clutch on the boom hoist shaft has to be engaged, which activates the second sprocket of my twin sprockets, which makes it move in clockwise direction. That leads to the clockwise direction movement of the sprocket on the shipper shaft and the clockwise movement of the crowd pinion, leading to the backward movement of the dipper stick. Now, coming to the boom hoist drum, similar to the bucket hoisting. So, in the boom hoist shaft, we have a clutch here, which again gets engaged to a free boom drum here, which you can see this rope gets winded. Now, since this clutch is keyed to this shaft, boom hoist shaft. So, now when it gets engaged with this drum, which is a free drum, so it starts moving in clockwise direction and it starts winding, which leads to the lifting of the boom. Now, when the boom has to be lowered, again it has to be lowered under its own weight. So, that is why there are brakes which are given here, which helps in controlled dropping of the boom under its own weight. So, there is no mechanism of unwinding these ropes. However, the mechanism is it falls under its own weight. Now, in next class we will be discussing about the swing and propel shaft transmission mechanisms. For reference, you can follow the Peter Darling book of the SME Mining Engineering Handbook. There is another book by Ratan Raj Tatia, that is Surface and Underground Excavation, and there is another book by Amitosh De, that is the latest development of heavy earth moving machineries, which you can follow this for this part of the lecture. Thank you so much. See you in next class.